Okay, so in this video, I'm going to go over from 4-6 inverse relations and functions, day 1. We're going to look at examples 2 and 3a so that we can identify how to find the inverse of a function algebraically and how to determine whether the inverse is a function algebraically. So we're going to start with the equation f of x equals negative 3x plus 5. Whenever I'm writing the algebraic inverse of a equation, I'm going to change f of x to y so that I have an equation that has y in it. So I'm going to change it to y equals negative 3x plus 5. And then I'm going to switch the roles of x and y. So that literally means I'm going to change any y that I have in the equation to x and vice versa. So this equation becomes x equals negative 3y plus 5. In order to identify this as whether or not it's a function, I want to solve for y. So I'm taking the equation where I just switch the roles of x and y, and I want to isolate y. So I'm solving for y. So I want to subtract 5 from both sides. Remember that this is just a reorganization, so it's unlikely that I will have any like terms to combine. So x minus 5 equals negative 3y. And then to get y by itself, I would divide both sides by negative 3. So one thing to note is that this equation, x minus 5 over negative 3, is an acceptable way to write the inverse of the function. However, if this were a multiple choice question, it could be that they simplified this to be in slope-intercept form. So remember that when I have a linear function, it's typical for it to be in slope-intercept or y equals mx plus b form. In order to do that, what I'm doing is taking and splitting up or dividing both pieces by the negative 3. So instead of dividing all of x minus 5 by negative 3 like we did, I could have taken each term, x divided it by negative 3, negative 5 divided that by negative 3. And that will give me something that I can create into y equals mx plus b form. So the x has an invisible 1 being multiplied in front. So if I simplify this, 1 over negative 3 becomes my m. So negative 1/3 is the m. So our slope is negative 1/3. Negative 5 over negative 3, the most I can do is know that dividing two negatives turns positive. So that is equivalent to negative 1/3 x plus 5/3. So when I write this, I'm going to write both of them just so that I have that reminder that if this is a multiple choice question, I could have two correct answers. So it's either x minus 5 over negative 3 or negative 1/3 x plus 5/3 as my equation. What I need to do is think about the graph of the original equation to determine whether or not the graph is a function. So the way that I do this is I'm looking at something called the horizontal line test. So if I know what the graph of the initial function, the graph of f of x, looks like, I want to think about if I were to draw a horizontal line, would it cross the graph once or more than once? So if it crosses the graph only once, then it passes the horizontal line test, and that means that the inverse is a function. If a graph fails the horizontal line test, like this parabola here, that means that the relation is not a function. So if I think back to the graph of f of x, negative 3x plus 5, my m is negative 3. So that means that my slope is telling me to go down 1 and down 3 to the right 1. The b is 5, and so that's telling me that the y-intercept of this graph is at 5. So if I think about this, that means that I'm going up 5, and I have a point, and then I'm going down 3 over 1. I'll do it one more time for good measure, down 3 over 1, and that's the graph of f of x. So what I want to identify is if I were to draw horizontal lines, would there be any horizontal line that would cross that graph more than once? And the good news is that this one does pass. And so since the graph of the original equation passes the horizontal line test, we are going to do this step. We're going to write this instead of y equals as f inverse of x equals f inverse of x equals. Okay, so our answers are here, and because this is a function. So if we think about that idea for these other two graphs, so if I just quickly sketch a graph and think about what the shape of this is, so without even drawing the axis, if I have a square root function, I know that graph is going to look like this. So that tells me that no matter what, if I draw a horizontal line, it's going to pass the horizontal line test. So that means my inverse is going to be written as f inverse of x. If I think about the graph for the second part of example 3, if I have x squared minus 9, that's a parabola, which was the one in the example that failed. So notice that this fails the horizontal line test. And so what that means, whoops. Let me erase that. So that fails the horizontal line test, which tells us that the inverse is going to be a y equals equation. So we are not going to do that last step where we replace with f inverse. Okay, so without actually graphing the equation all out, we know what the shape of the graph is, so that can tell us about what our last step entails. So we're going to start by changing f of x to y. So this equation is going to be y equals the square root of x minus 2. The next step in finding the inverse is the most important one. We're going to switch x and y. That's the idea of inverse. So that's the big takeaway from this section, is that to create an inverse function, I switch the role of x and y. Then I want to solve. So in order to solve this, I'm going to square both sides to get rid of the radical, because the y and the 2 are both stuck underneath the radical. And so if I square both sides, that leaves us with x squared equals y minus 2. And again, we have that because of the inverse operation, square root and square. Finally, to get y by itself, we need to add 2 to both sides. So x squared plus 2 is equal to y. And we already talked about, because this is a function, we're going to write it as f inverse of x is equal to x squared plus 2. So both of those things are the answer, because it's asking us to find the inverse and determine if it is a function. So for the last one, we have x squared minus 9. We're going to change f of x to y. So y equals x squared minus 9. Then we want to switch the roles of x and y. So y is going to become x, and x is going to become y. So now we have x equals y squared minus 9. Our goal is to isolate y. So in this case, we want to add 9 to both sides. Again, we're usually just rearranging, so it shouldn't be able to combine. In this case, that's true. So x plus 9 equals y squared, and those 9's cancel. And then to get y by itself, we're going to take the square root of both sides. Remember that when we take the square root of something that's squared as an inverse operation, that always results us with plus or minus, because 4 squared can make something, as can negative 4. So they make the same value. One thing to keep in mind is that when I have this, the square root of x plus 9, it is not equal to the square root of x plus 3, right? I cannot just split up a square root when it's adding or subtracting. However, if I had 9x and I was square rooting that, that's when I can take the 3 out of the radical. And so this is just going to stay the square root of x plus 9. And then remember, our big idea here was that we were trying to get y by itself. And so since the inverse is not a function, our answer is going to stay y equals plus or minus the square root of x plus 9. So the big idea for this lesson is that I can reverse the roles of x and y to create an inverse of a relation. I want to check to see if it passes the horizontal line test. If it is a, I want to see if the graph of the original equation passes the horizontal line test, and that tells me whether or not the result, its inverse, is a function or not.